Hi everyone, welcome to Advanced Functions. This is a new chapter called a Trigonometric Functions. In this lesson number 1, we're going to explore how to use a radian measure to represent the size of an angle. First of all, we need to understand what is an angle. So angle is a region between where there are two rays. And there is a starting point from a vertex point. Okay, so if I have to show you, for example, let's start. This is a representation of a line. Okay, a ray, on the other hand, ray is from a point to an arrow. And if I want to represent an angle, then you have something called an arm, and these arms are connected by a point called a vertex. And this is an angle. An angle is represented using a Greek symbol called a theta. Now, a straight angle is represented using a straight line. Okay, let's say this is my vertex. This angle is going to be 180 degrees for a straight angle. Okay. Now, a right angle is where you split the straight angle. So from here to here, this is 90 degrees. Okay, perpendicular to the line. And anything that we call an acute angle is less than 90 degrees. So for example, this is an acute angle, meaning less than 90 degrees. But if we have an angle that is greater than 90, we call it an obtuse angle. So from here to here, this is obtuse. So obtuse is greater than 90, okay, but it has to be less than straight angle. Okay. Next, reflex angle. Reflex angle is an obtuse angle, but it's greater than a straight angle. So for example, let's say we have a line here. From here to here, this is definitely greater than 90 degrees and greater than a straight angle. This, we call it a reflex angle. Okay. And lastly, if we have something called a full turn angle means you are coming back to your initial arm, meaning all the way up and then coming back. That is a full turn. So that means if you have done a full turn angle, it must be greater than 360 degrees. Now, to understand angle a little bit further, first we need to understand what a standard position is. So standard position is represented on a Cartesian plane. So this is x. Okay. So the initial arm is always represented on a x-axis, on the positive side. This is called an initial arm. And then, let's say we have, this is called a terminal arm. So angles are always represented from initial arm to where the terminal arm is. So that is a standard position. Now, what about the sign? So what I mean by sign is that if we are going in a, let's say, this way, counterclockwise, if we're going counterclockwise, that means the angle is going to be positive. So in this diagram, it looks like it's definitely greater than 90. So we could say the angle is positive 120 degrees. Okay, but on the other hand, if we are going in a clockwise setting, this way, So how this clock is moving, we're following that. That means it's going to be a negative angle. So what do I mean by that? So you always, again, start from the initial arm. From here all the way to where the terminal arm is, this is going to be negative. So the whole cycle is 360. So 360 minus 120 is going to be 240 degrees. So that this angle from the initial arm is going to be negative 240 degrees. Okay. Now let's try an example. I do want to point out what are some of the key important angles. Now from initial arm, this is going to be 0 degrees. This one is 90, okay, perpendicular. And this one will be 180 degrees. And then at this point, it's 180 plus 90, so it's 270 degrees. And coming back, it's a full turn, which is 360 degrees. So these are the axis angle that you should memorize and understand when we are looking at the proportionality of other angles. So for letter A, it's right on the north over here, 90 degrees. So A is going to be 90 degrees. For letter B, it's a straight angle, but for this one, we're going in a clockwise setting. So therefore, it's going to be negative 180 straight angle. Now letter J, so it looks like it's definitely greater than 90, but less than 180 degrees. So approximately, it's a 2/3 of it. So 2/3, it's going to be, this is 30, this is 60, and this is 90. Right? So 60 plus 90 is going to be 150 degree, but because we're going in a clockwise, it's going to be negative 150. Next, it looks like we have done a full turn. So this was 360 and then plus 90 degree. So that's going to be 450 degrees, positive angle. Now, so we are going to move on to a new angle measurement called a radians. So angles can be measured also in radians. And radians, what it means, it's a ratio between the arc length represented from a radius length of a circle. So this is the formula to represent a radian. So what do I mean by this? So if I have to show you a diagram, so this is like a unit circle. So we have a radius. This is R, radius. And let's say we have a terminal arm, which is over here. Okay. So therefore, the S in this case, which is the arc length, is represented using over here. This is the length of the arc, S. And this is the representation of R. Therefore, if I have to figure out the angle, the alpha in this case is represented from here to here is the alpha. So measure, which is in radians, in radians, is equal to the length of the arc, which is S, over the length of the radius of a circle. And that is a formula that you have to keep in mind. So let's see, find the measurement in each angle in radians. Now, again, there is some pointer that I want you to remember in terms of radians. So we looked at the angle in Cartesian plane, 0, 90, 180, 270, and 360. So same thing for radian. If it's 90, it's going to be pi over 2. If it's 180, it's going to be pi. If it's 270, it's going to be 3 pi over 2, 1.5. And if you have one full turn, it's going to be 2 pi. So therefore, one whole circle is the 360 degree is 2 pi, and half of that, which is a straight line, is going to be pi. Okay, so these are the Cartesian angle in radians, which I think you should have it memorized. So let's see. For letter A, it's representing half of a straight line, which is pi over 2. And we have a straight line that is going in a negative direction, right? It's going clockwise. It's going to be negative pi. And then we have so this, we said it's going to be, this is, so 30, another angle, the special angles that I want you to memorize is, we're going to talk about this, but 45 degree is a special triangle, which I'm going to show you later. And we have 30 degrees and 60 degrees. So 45 degree in radians, if I have to convert it, which I'm going to show you in a second, is going to be pi over 4. 30 degree is going to be pi over 6. That's the equivalent. And 60 degrees is going to be pi over 3. So because this is a 2/3 of it, 2/3 is going to be pi over 3, and it's greater than 90, which is pi over 2. So if I have to add them together, 90 plus 60 degrees with the common denominator, it's going to be 5 pi over 6. And because it's clockwise, it's going to be negative 5 pi over 6. Next, this is a full turn. So we have done a full turn, which is 2 pi. And then after the full turn, we have 90 degrees, which is plus pi over 2. So when I add them together with the common denominator, it's going to be 5 pi over 2. Okay, so again, this is measuring angle in radians. Now, so you may be wondering, what if it's not like a special angle and not is on a Cartesian plane? So there is a conversion formula from degree to radian or radian to degree. And it looks like this. 180 is equal to pi times radians. So let's say if I want to convert this into radian into degree, that means the degree has to be at the top. So if I have to rearrange this formula, it's going to be 180 over pi. So this is a conversion multiplier that you're going to multiply if I want to change from radian to degree, because this is equal to a radian. On the other hand, if I want to go from degree to radian, so that means the radian has to be at the top for pi. So I rearrange, so it's going to be pi over 180 degrees. So this is going to be a multiplier that I'm going to multiply to the degree to change my unit into radian. So this you must memorize, okay, which is derived from rearranging the formula. Okay, so let's put this into practice. Now let's convert letter A, 10 degrees into radian. So 10 degrees means that we're going from degree to radian. So degree to radian, we said that. We are going to multiply by pi over 180. If I'm going from radian to degree, I'm multiplying 180 over pi. So therefore, in this case, I'm going to do 10 degree times pi over 180. So in this case, degree and degree cancels out. So 10 pi divided by 180 is going to give me pi over 18, which is about 0.175 radians. So if you have to finalize your answer, I would preferably you represent using an exact answer in radian, which is pi over 8. Okay. Next, we have a -1 degrees. We are going from degree to radian, so we're going to multiply -1 degree times pi over 180. So degree and degree cancels out. I have negative pi over 180. So therefore, this is going to be about approximately 0.017 radian. Okay. Next, we have square root 2 radian into degree. So if we are converting from radian to degree, that means we're going to multiply by 180. So square root 2 times 180 divided by pi. So you can't really simplify this because it's a square root. So approximately it's going to be 81.03 degrees. Now, when you don't see a radian in the unit, it means, and you see pi, that means it's going to be in radian. So we have 5 pi divided by 3. So then it's going to be 5 pi over 3 times, I'm going to change it into degrees, so 180 degree over pi. So as you can see, pi and pi cancels out. So I'm going to simplify. 5 and then 3 and 180 cancels out. So 3 becomes 1, it becomes 60. So 60 times 5, it's going to be 300 degrees. Okay. Very easy. Next, so arc length. So sometimes in the question, they may ask you to find the arc length. So arc length is represented using this formula. Okay, so we saw from the previous note that this is the radius and this is the arc length. Okay, and this is theta, the angle. Okay, so I can rearrange this. If I'm looking for theta, theta is equal to the arc length over the radius. Let's see. So find the length of the arc by an angle of 50 degrees on a circle of radius 30. So formula S is equal to the theta angle times the radius. In this case, it's going to be 50 degrees times the radius is 30. Therefore, because you have to represent it in a radian, right? Because the arc length is in radian. So 50 degrees, I'm going to convert it. So 50 degrees times pi over 180. So degree cancel, and I reduce it. So it's going to be 5 pi over 18. So 5 pi over 18 times 30. So it's going to be 8 pi over 3 centimeter, which is approximately 26.18 centimeter. So that is the arc length represented by angle of 50 degrees. So if I have to draw, this is the radius of 30. And let's say we have about 50 degrees, so it's less than 90. So this is 50 degrees. This length from here to here is 26.18 centimeter. Okay, next. A wheel is rotating at an angular velocity of 1.2 pi radians per second, while a point on the circumference of a wheel travels 9.6 pi meter in 10 seconds. When we're talking about angular velocity, there is a formula. So the formula is equal to, V is equal to radius times angular velocity. So V represents the velocity. So it's a linear velocity. R is the radius. And A is the angular velocity. Okay, so letter A, how many revolutions does the wheel make in 1 minute? Revolution means one full cycle, okay, which is 360 degrees or 2 pi. Now we're given that the wheel travels 9.6 pi in 10 seconds. So 9.6 pi in 10 seconds, and we want to find it in per minute. So we're going to do a unit cancellation. We want minute to be at the bottom, 1 minute. 1 minute is equal to 60 seconds. So seconds and second cancels out. And this 10 divided by 6, so this becomes 1, this becomes 6. So it's 9.6 times 6 pi, which is about 57.6 pi per minute. So that's how long this is how much revolution it's going to take for if you're given 1 minute. Next, what is the radius of the wheel? Now, to find the radius of the wheel, then we have to use the angular velocity formula. V is equal to radius times angular velocity. So we know that, because we're looking for the radius, let's rearrange. R is equal to V over 8. So V, we know it's going to be 9.6 pi over 10 seconds, which is about 0.96 pi. And angular velocity is 1.2 pi radian per seconds. So they're both in seconds, which is perfect. So therefore, radius is going to be 0.96 pi over 1.2 pi is equal to 0.8 pi meter. Okay, so this one is, because the velocity is this one is radian per second, and this one is meter per second. So second cancels out, and this is already radian, so therefore you're left with meter. So that is my radius of this wheel.